Hi folks, Tom Affolter back again, and today we're going to continue our discussions on classes. We're going to discuss some more sophisticated classes today, although we're going to take a look at it from a real simplistic approach. But keep in mind, classes are everything that we're programming, be it a form. We took a look at the PODs previously. There's another type of class that's generally referred to as a business object. And a business object would be a class that an organization would maintain that handles perhaps as a class all their sales, perhaps inventory, all their shipping, everything else associated with that business. The purpose of that would be that then once you design that business class, you could utilize that off of a website, the same class, off of a desktop application, and off of mobile apps, if you will. Once you make a change to that class, it's immediately made to all those additional applications that are utilizing that class. Again, that assumes, as we talked before, that they have direct access to that class change. Otherwise, you would have to send them the physical class. But we're talking about within the same development environment. So the very first thing I want to do is talk about how do we get data into a class. And there's three common approaches to get data into the class. We took a look at one previously when we did the PODs, that's properties. So we can pass data to a class through properties. We can also pass data through methods. We saw methods before. We can make a method public, and that method then can be utilized. We could pass a value to the method, and then it can kick back an answer, assuming that it's a returning method or a function. Another thing that we're going to take a look at, and we've already experienced, are constructors. And constructors are methods that, if you will, they're not truly methods, but they look and smell like a method, that automatically execute when a class is instantiated. Where did we see that before? We'll go back and take a look at that in a minute here. But where we saw that was when we were dealing with our connection string and our command objects back in the ADO exercises that we did. Let me take a look and show you what I'm talking about. Here's an example of an ADO exercise that we looked at earlier. You'll notice in here what we did was we created a string. We stored the connection string to that variable. Then we took that variable and we applied it now to that connection string. Here's an example of a property right here. So that connection object had a connection string property, and we're passing in the connection. But we also looked at another way to do exactly the same thing. I could have bypassed this entirely, as we saw before. Take this out and take the connection string right here. That's the older connection string, and paste it right here in the middle. And now what I'm utilizing is I'm telling it when you instantiate the object, pass into it at the same time the connection string, and that then will apply. It does away with me having to use the property. It applies that property directly to that connection. Here's an example of utilization of a property method. Again, both of these apply here. Here's an example up here of using a constructor to pass the information in. And we're going to take a look at all those examples here in just a moment. On this screen, we see an example of that ADO where we use the drag and drop and the code that was automatically generated for us. So notice what we've got here. We've got an object that's called batting table adapter, and we've got this fill right here at the end of it where we're passing information into it here. Well, what happens is you notice I'm not instantiating batting table adapter. It's already been instantiated. That means that fill is a method, and what I'm using now is I'm using this fill method to do something, and I'm passing this into it. And basically this is a void method where it simply goes out, grabs the data, and fills this data set with information behind the scenes, that generated code. Real briefly, we've looked at three different methods that we're going to dive into in just a second. We took a look at, number one, how we pass information in via a property. That connection string where we set it to a variable, and then we put in, and let's go back to that example right here. So here, we initially set the connection string to a variable, then we went back in and applied that variable right here to the property. One method. Okay. Now, of course, what I could have done is I could have bypassed everything and done this. Not used a variable. It would have been the same technique. Could have gone down here pasted this in and applied the connection string directly. But nonetheless, I'm still using the connection string property, and I'm giving it a value initially. Of course, when it runs this, folks, what it's doing is it's applying a setter. It's setting the value of connection string to this value right here. So when it runs this to this object, it's being passed to that value variable, as we're going to take a look at here again in a moment. We saw that previously when we were doing the PODs. This is an example again of using the property method. This up here would be an example of using an overload method. And then of course the other example that we looked at is an example of how we pass information into it directly through a method. And we didn't have to use a constructor. We went directly to the method in this particular case right here. So let's go back in. Let's take a look at all three of these examples, because when you write an object that you want to be usable, or a class I should say that you want to be usable, you want to make sure it's usable by all different types of programmers. And you're going to find out that there's some programmers that love to use constructors. There are programmers that would prefer to just instantiate the object and pass the values into the object through properties. And then there's other programmers that strictly want to use methods. They bypass, they say no constructors, no properties. I'm just going to call a method up and I'll pass the value directly to that method. To get started, we're going to write our program in baby steps. We're going to start off, number one, by creating methods. And those are going to be public methods, and we're going to utilize that class and see how the public methods work. Then once we finish the public methods, we're going to go back in and add properties. Now when we add properties, it's going to require us to change our methods a little bit, but we're not going to change the methods that we were using. I want to make this approach usable by all aspects. So we're going to add or overload the existing methods that are there. And then once we're done with that, we're going to go back in and we'll use a constructor and show how a constructor can add a little bit of pizzazz to your object and make it more usable as well. So this example that I'm going to create will be my toolbox. Now when I say my toolbox, I could create a toolbox, I could create a business object. We're going to start off by creating a toolbox. Again, remember, the business object might have all my methods, everything that I do, I need to solve my business's formulas. So examples would be the shipping information, as I mentioned before, inventory. But in this particular case, I'm going to create an object that I'm going to use as my toolbox. And the advantage to that is I can go back in and add methods or properties into my toolbox. And then as I write programs later, I can take that same toolbox and utilize it in my future programs. And it's going to save me a lot of time. It's also going to save the client a lot of time as well, because these methods are already going to be tried and true. But of course, we're going to keep them really simple for this example. So let's start off with by creating an empty class. New project. And I'm going to create a class library. And my class library I'm going to call Tom Tools. And let me see where I want to put this on my computer here. I think I'm going to put it out on my drive C. And I'm going to go ahead and click OK. So what I've done before I go on is I've selected the class library. That's going to just give me an empty class that it expects me to work on. I'm going to call the name of the solution Tom Tools. That means that users will be installing tomtools.dll if I was to hand it to them. But that doesn't mean that's the name of the class per se. So let's continue on. I'm going to click OK. It's going to build that basic class design for me. And here we go. So here you see the name of the package or the library is Tom Tools. The name of the class right now it thinks I'm creating is class 1. I could have multiple classes in here. So let me copy this, paste down below. Now it's going to give me an error because it's already got a class 1. I'm going to put a class 2 in here. And I could have whatever I want, as many classes in here. And that's really what a library is, or a DLL. It's one or more classes that are packaged together. This class right now would be called tomtools.class1, tomtools.class2, and they would be instantiated separately, not together. Let me get rid of this second guy here. We're going to focus on 1 now. Now, normally you're not going to have a class called class 1. I'm going to create one over here. I'm going to call it tools. So I could edit it here and call it tools, but really the proper approach is to make sure that the namespace matches the name of the class. So the best way to do that is to simply come back over here in your Solution Explorer and rename your class. So in this case, I'm going to call my class tools.cs. Go ahead, and I'll watch what happens when I click outside of it. It's going to tell me that it expects both these names to match. Yes, I want them to be changed. And now I've got these tools. So if I was to compile it right now, which I could, let's just go ahead and do that and build it. It's going to build for me a DLL, even though there's nothing in it right now. And the DLL will be called Tom Tools, but to instantiate it, I will instantiate tomtools.tools. And here's the name of the DLL right here that it's just created for me in the location of where it's at. Initially, what I'd like to do is to go back in there and create a couple of methods. These are methods that I might have in my toolbox, and of course I'd have a lot out there. And I'm only going to put 3 different categories of methods in. There's going to be more than 3 I put in, but I'm going to put 3 in. The first one I'm going to put in is one that is numeric. I use it all the time. Visual Basic has a isNumeric method built in, but C# doesn't, and it's not hard to write. I need it though periodically. I want to know, is something that I'm passing in numeric? Maybe I'm looking for a zip code and I want to make sure all the digits are numeric on that zip code. Or I'm looking for a dollar amount and I want to make sure nobody fat fingered and put a letter in. So all I want to do is pass something into it and have it tell me, return back to me, whether or not it is numeric or not. So let's go ahead and write that out. For me to make this available, notice right here when I created it, this class has to be public. Why does it have to be public? Because I got to be able to get to the stuff, to the class itself and the stuff on the inside. If I made it private, it would be pretty much useless. That means outside of Tom Tools, I could never get to this class. So it has to have what's called a modifier of public on here. And in fact, anything I want my users, the people that are going to be using these tools to get to, it all has to be public as we had with variables previously. So I'm going to create a public, and I want to have a Boolean return. So it's a value returning method, and every method that I put in here is going to be a value returning method in my tools. I'm going to call it isNumeric. And for this to work, I'm going to expect that somebody's going to pass something into me, which is a type string. So they're going to pass something out of a text box into me. They're going to pass in a zip code to me that's as a base type string, and I need to make sure all the characters in it are numeric. So I'm going to receive it as a string, and I'm going to call it testNum. Now, why am I calling it testNum and not putting str in front of it? The reason is when a user comes back and instantiates this object and they try to run isNumeric, what I want to have happen is just what you see right here. I want it to tell the user that to use me, here's the signature. I want you to pass in a string, and that's what I'm going to test to see if it's numeric or not. Now, if I put str in front of it, most people would probably understand what it is, but it's probably a little bit more informative not to use Hungarian notation when you're dealing with these objects, because you want to describe it to the user. In here, I'm going to test to see if a value is numeric or not. So it means I have to return something. That's what the error is. I don't have a return in here. So to test whether a value is numeric or not, the easiest way to do that is to create a variable. So I'm going to create just a throwaway variable here. I'm going to call it myInt is equal to, and then I'm going to do a parse. And I'll do an int.parse of that string testNum that was just passed in. If that number that was just passed in is numeric, everything's going to work just perfectly. Meaning that if I pass in a zip code that's a character like 99207, it's going to try to move 99207 in an integer. It's going to work perfectly. But the problem is if I pass in something that has a letter in it and I try to parse that letter, I'm going to get a syntax error on this line. Well, that's a good thing because I want to harness that. I want to catch that. So let's put a TryCatch in here. Okay, so there's my basic of TryCatch. I want to try this portion right here. Okay. If that works, no errors is received, I want to return a true, which means it's got to be a number. Else, I'm going to receive an exception. I don't care. I don't even have to look at what kind of exception is. Else, I'm going to return a false. That means that it's going to get to it's going to cause an error, and that means it's not numeric. Something in it's not numeric, and there, folks, is my isNumeric method. I'm going to create a couple others real quickly here. Let me create one. Clean up a little bit of white space here. I want to create another method that returns back to me a proper name. So I'm going to create a public method. I want to return back a string. Oh, and I'm going to call it getFullName. And I want the user to pass into me a string. And they're going to pass me the first name, and I'm just going to call it first name, no Hungarian notation because I want that to pop up. They're going to pass me another string, and that's going to, string, and that's going to be spelled right, and that's going to be last name, just like that. And then when they do that, all I want to do is return to them the first name plus a space plus a last name. So if they pass in Fred and they pass in Flintstone, it's going to return one string Fred Flintstone with a space in between it. Now I'm going to overload that as well. I want the user to be able to do one other thing. So I'm going to copy this guy. And I'm going to paste them down below here. And I want the user to be also to have the opportunity, should they wish to pass in a middle initial. So first name, then I want a string, and I'll do middle name, and a comma. I could have put all that up here and tested to see if there was a middle name that was passed in, but this is a much easier way to do it. I've overloaded it so I can run it. So I would do first name plus a space plus middle name plus a space. So I'm making it more user friendly. Again, you've got getFullName here. When you run this, it's going to give you two different overload methods. It's going to tell you that you could either use it by just passing a first and a last name in, and I'll just return back to you that name concatenated together, or you can pass a first, middle, and a last, and I'll return all three of those concatenated back to you with spaces in between it. Okay. The very last one that I might want to do is a date. Now there's this really cool feature that we have in C# that allows us to create a date object, and it verifies there's a date, but occasionally what's going to happen is we're going to read a date in, and it's going to be as a string, and I want to know, is that string that's being passed in, is that a valid date or not? And the fact is I can do it exactly the way we did it up here to test for a date. So that's exactly what I'm going to do. I'm going to come back down here because I'm a lazy typist and I'm recording this. I'm going to copy that same method down. But this time I'm going to, and I'm receiving a string, but I'm going to say this is going to be called isDate. I'm going to pass in I'll call it a date string. I'm going to then parse, I'm going to create a date time variable here. I'll call it myDate. And then I'm going to do a date time parse. This is cool. And I'm going to parse over here date string. So it works exactly the same way as we had that previous test for numeric. You're going to pass in a date. It's going to try to parse that date that you passed in as a string into a date variable. If that is not a valid date here, we're going to generate an error, which will jump us down to the exception here, and that exception will return a false, telling us it's not a valid date. Otherwise, it will then return a true, which means it is a valid date. So let me go ahead and let's build this. Make sure everything works. It built it. It tells me where it's located at. let me jump across and let's create an application that we can use to test this. So I've created a basic Windows form application. Let me go ahead and set the font size on it so we can see it a little bit better. And of course, I'm not going to spend a lot of time on the test app, just enough to show you basically that it's working. So let's just start off by doing a couple of small tests on here. I'm going to throw a button out here. And then let's throw a text box. Put a label at the bottom and then a text box to the right of that. And then on that button, I'm going to just put the word test on the button. I'll call it button test. And I'm going to call this text input, because I'm going to use this to test a variety of those different methods in here. So I've got this test button here. And then I'm going to call this label output. So I want the results of whether these tests produce a true or a false, or a first name and a last name. But we're going to test, first of all, those that take input as an individual value. So I need to go back in and add my references. That tool's not here. So I'm going to do a right click under references, add reference. I'm going to now browse to my drive C and find my tools. There is Tom Tools right here. Let's go into Tom Tools, into my bin folder and debug folder, and there's my tomtools.dll. So I'm going to double click it and then click OK, and it's now added Tom Tools in. So what I'd like to do right now is I want to test to see if what I type in that text box is numeric. I want it to come back and say true or false down here, just to test it, see if it's working. So let's go ahead and put that behind the test button here. And the very first thing I need to do is instantiate an object. So that's what I'll do. I'm going to take my Tom Tools. Remember, the name of the package is Tom Tools. There it is, Tom Tools, dot, and there's the tools that I created. Now I got to give it a name just because I'm declaring it as a variable, so I'm going to call it my tools. I can call it anything I want. Now if I left it at that, it would only instantiate the memory needed to store Tom Tools, but I want Tom Tools with all those three methods included in it. So for that to happen, I have to type this in, equals new Tom Tools. Before I go on, that right there, as we're going to talk about in a minute, represents the constructor. But we're going to leave it alone as it is right now. So when you click the button, I want to create a Tom Tools. Let's take a look at what my tools, let's change that, what my tools has in it. So I've got my tools dot, and you're going to see there's a get full name in here, there is an is date, and there's an is numeric. Let's try and start off with is numeric. So what I'd like to do is I want that label that we created, .output.text, to be the result of that test. So what I want to do now is I want to do my tools dot is numeric. Now notice what happens when I do the is numeric. It pops up and tells me now how to use it. That's why I used testnum over there when I named it and not str testnum, is because it tells me a little bit of information about it without using Hungarian notation. I'm going to pass in the information that's in that text box. So is numeric, boom, information in that text box input dot text. It's going to return back a true or a false, but I'm trying to put it into a string. So in order to move it to a string, same thing with a Boolean, is I've got to do a dot to string at the end of it. And let me back up here before I go on. Had you pointed to it, you would have seen that it said that. I can't do a Boolean to a string, so it gives you a pretty good idea that you have to do a to string at the end. Let's go ahead and run this, as simple as that is, and see if it works. So I'm testing to see if the number is numeric. Let's type in 1, 2, 3, test. True, it is. How about 1250 test. It's not. Isn't that a great routine? And you could use that over and over again, put that in a toolbox. Now all of a sudden you have your own custom tool. And I'm going to show you in a minute some even easier ways to utilize it. But for right now, let's leave it at that. Let's change our application around a little bit now. Let's test for date. Let's just see if our date's working. So now what I want to know is what is inside that text box a date? This is how simple it is. Right here. Dot is date. I've now changed it around and it should work the same way. Let's find out. 34, is that a date? Nope, it's not a date. How about 12/12/2017? Is that a date? It is a date. So it shows you some really cool tools that we could put in. Let's continue and do one more test on here. So the next thing I'd like to do is to come back in and let's go to the form. Let's add in another text box. And that's going to be first name and last name, and we want the full name to show up here. We'll test that one out. So when you click the button, I instantiate the object. Then what I want to do is I want the label to be equal to, and let's get rid of this right here, my tools dot, and then I want to get full name. Now notice there's only one get full name listed there, but I created two. Watch this. If I hit my tab key in my left parenthesis here, it tells me there's two variations of the get full name available to me. One is asking for the first name and the last name. The second one is asking for a first, middle, and a last name. So let's do the first one. We'll pass in what is in text input dot text, and before I continue, let me change this one to text input 1. There we go. Now go back to the code again, and then what I want to do is I want to pass in a second one. Text input 1 dot text. And I don't have to tell it which one of the two methods to run. It knows because it's going to run the method that receives two arguments. There's only one of them that does. Let's run this and see if it's going to work. There we go. And if I was to go back in and add in another text box below this one, and we'll call this, so that was text input 1, text input 2, and let's test it out. So now I've got 3 items to put in. So I'm going to add in the third argument, and it will automatically know which one to run. Let's try that and see if it works. There you go. So there's our tools working, and what we've done is we've used the method approach. The method approach, and it works just fine. And some developers, they'll choose only to use that method approach. And the method approach says, look, I want my tools only to use public methods, and I'm just going to pass the values in. That's all you have to have. Again, some toolboxes, this is all that's going to be out there. And in fact, in my toolboxes that I create for myself, I use the method approach, just like this. All of my tools I create will be methods like this that I return back. And as I write programs and I see that something valuable is created in my application, I will take that, if I know I can reuse that in different programs, and copy it over to my tools so that later when I compile it to a DLL, I can use that in every program I write. And again, that toolbox builds up and builds up and builds up over time. Let's continue on, and now let's talk about adding properties to it. Just as we did before, you add properties the same exact way as we did within the POD. The easiest method to do would be to go back in and add a class diagram. You don't want to use the get setter shortcut here. You have to use the larger method, and the reason is because within the program you're going to need to have helper variables. The first issue that we have is the way that these guys are being used right here. They're expecting us to pass in a value. But if we use properties, we shouldn't have to pass a value in. The properties should be able to provide the values that we have here. So that's what I'm going to do right now, is I'm going to create this guy, and I'm going to have one little hitch here in a second. I'll show you. But I'm going to take this guy right now. Okay, I'm going to go ahead and copy him, and I'm going to paste him down below here. I'm going to overload him. But this time I'm going to take out this argument entirely right here. And the reason I'm getting an error is because I've got two signatures exactly the same thing. Boolean is numeric and a string property. Boolean is numeric and a string property. The moment that I change the signature, nothing in here, that error then should go away, as we see there. Now, of course, it didn't go away here because now it's saying, where the heck am I going to get the value from? We're going to get that value out of a property this time, folks. Let's go ahead and add into our project a class diagram. So I'm going to add in a new item. I'll add in a class diagram. Just like that. And now I can take these tools that I just created and drag them over into my class diagram. And it shows me currently what I have. Notice it lists them as just methods. So what I'd like to do now is I'm going to need to add a couple of properties. Because these guys, for them to function, it will need to function from properties. And for right now, I'm going to just deal with isDate and isNumeric. So let's start off with those two providing data. So I'm going to go ahead and add in a new property. And the property that it's going to receive now is going to be the same kind of property that we had declared down with the methods. So they're going to be of type string. And the first thing that I'd like to do is I'm going to put in let's use the same values that we had over here. Take a look at this. Before I go on, my naming convention down here was testNum. So I'm going to create some variables that are very similar that will be the same. I'm not going to use the same name. And I'll show you in a minute why. I don't want to get confused between the program, between a variable and a property that have exactly the same name. So I think what I'm going to do is I'll call one numTest, and I'll call one stringDate, something like that. Let's do that. Notice what it did is already created that basic property for me, even though I haven't finished it within the class diagram. So I'm going to come back to this class diagram here, and I'm going to call this one stringDate. It's receiving a type string. If I made this right now of type date and you try to pass the value, it's going to generate an error. I want to receive the string date to determine is it a date. So I'm going to make that on the bottom right corner here of type string. Then the next one I'm going to create is I'll call the other one the same way, stringNum. So I'll create another property and I'll call that one stringNum. And I better be consistent, lowercase. stringNum. And of course that's also going to be of type string. So let's look at our program, see what it's done for us. So it's added in stringDate and stringNum for us, but it hasn't done the getters and the setters. When somebody asks what is the value, we need to have a variable that's going to hold the stringDate and the string number. So we're going to create helper variables, or sometimes they're called fields, up here of type string. Now these are private strings, means there's no reason for anybody on the outside to see these variables. Private is implied. If I was to create those though with the builder, it would not imply it. It would have actually typed in private in front of it. Makes no difference because any variable created is automatically private anyway. But let's go ahead and do that just to make the class designer happy. I don't like these variables that have a lowercase s. Let's change them to uppercase s. I can do it right here. And the reason I'm going to do that is because I'm going to use an O to define my helper variables this time. So in this case, I'm going to have an O string date. And it's going to be of type string. and then I'm going to have another string of ostring num. So when a value is passed through the string date property, it's going to be received by ostring num. When somebody asks what the value is of the string date property, we're going to return to them the value of ostring date. I'm sorry, of ostring date here. So these guys are married together. These guys will be married together, and let's make it happen. So right here, we're going to return, when they use a getter, we're going to return ostring date. We're going to set it by going back in and saying ostring date is going to be equal to whatever they pass in through that property window. And that's going to be of value, just like that. And we're going to do the same thing down below here. We're going to come down here, and we're going to return ostring num, right there. And when they set it behind the scenes, we're going to say ostring num is going to be equal to whatever value they decide to pass into it. And what's interesting about it is it doesn't matter whether this is an integer or a string or Boolean. It doesn't care. We don't have to tell it what value it is. We just have to catch it over here. So now I've got the properties created. What I need to do now is make it so that this is numeric. Now notice it's not receiving an argument. It doesn't need to here because it's now going to use is numeric. It's going to use the O string num here variable because it's going to assume it's already been set, just like that. That's what it's going to look at. And in fact, down below here with the string date, we'll do the same thing with this guy. When I copy him out here and I paste him down below, the ostring date now is not going to receive a value because it doesn't need to. When the object was instantiated, you used a property. So what property is it going to use? Or excuse me, not property, what helper variable? It's going to use the ostring date. So now based on what I have here, my program, the way it's set right now, is usable among a variety of different methods. I can either use the method approach. I still have to instantiate it, but I can use the method approach if I want to. Or I can instantiate it, pass a property value in, and then go ahead and utilize the application. So let's build this and see if we've got any errors. See no errors in here. So let's jump back to our test application. Right here. Here's my test app. And I need to change things around just a little bit now. So we're going to utilize it now to work with properties. So it's still going to go behind the button, but right here I instantiated the object. Okay. Here I passed the values in for get full name. So if I want to use let's not use get full name here. Let's change this back around a little bit. So I'm going to undo what I did before. Let's delete those out. Come back into my code here. I'm going to take this information out here. And what I'd like to do now is once I get this object instantiated here, my tools, I want to pass something to my tools. I want to say my tools dot. Now I want to pass in a string date property. These are my properties right here. So I'm going to say my string date now is equal to that first text box. Text input dot text. I instantiated it as my tools. I then said my tools dot string date. Where'd this come from? That's the property. So I'm going to pass into it this value, whatever's in that text box right there, to determine is that a valid date or not. Okay. What I need to do at that point though is the output has to change just a little bit. So my tools now, if I go back and look at my other object here, my isDate is just going to return a true or a false, with nothing passed into it. So let's correct that right here. And it's going to be my tools dot is date. Just like that. Of course, I'm going to have to do a toString on it. And let's see if this works. Let me back up one more time before I run it and make sure we understand what's happening. This was no different right now than when we used the methods. I had to instantiate the object so that I could use, at this point, my tools. So now I've got my tools available. Inside my tools, I created a property called string date. And I'm passing in the date to string date. Now notice I'm not passing anything in when I run it. The reason is because it's going to utilize, it should, if it's correct, this information. Let's run it and see if it's going to work. Okay, so I'll put in 12/12/2017 test. Uh-oh, says it's not a date. Oh, because I didn't put in 12/12. Ah, it worked exactly as it should have. Let's get rid of that extra one there and test it. Wow, there you go. So it shows you I could utilize it either way. And in fact, I still could come back in here and without making any changes at all, decide, no, I don't want to use this method. I want to use this method. Look how quick it is. I want to pass it in. Now run it. It works both ways. So just now you saw me use both different techniques. If it's your tools and your tools only and you're going to use it, obviously you get to dictate exactly how you want to do it. And my suggestion would be to use methods. That's the easiest way to utilize it. But if you're making this commercial or you're making for a business and you've got users that are going to be utilizing this, and I would suggest that you make it as versatile as possible. We've looked at 2 of the 3 different techniques on it. Now let's jump back and look at the third technique. Now this is probably not the best example to demonstrate a constructor because constructors really are more valuable when they're really focused on one specific concept or technology. For example, ADO.NET, you have that connection string that you pass into the connection object. Well, that connection object does only connections. The problem with this example that I have here is that constructors are not made to pass every single value in that all of these tools are going to use. It really is made to pass in a focus. So let's imagine that we have a simpler object here. And in fact, let me do this. I'm going to get rid of a couple of tools that I have in here right now. And let's imagine that the sole purpose of this object here is to deal with names. So I want to get rid of a whole bunch of stuff in here. So get rid of all of this right here. And I'm going to get rid of this for now. I've got these 2 different methods in here that deal with names. What I want to do is I want to have the ability that when the user instantiates this object that they neither have to use a method nor do they have to use properties. At the moment they instantiate it, they can go ahead and pass a value in. In order to do that, I need to create a constructor. And again, a constructor is for the sake of explanation, it's a method that automatically executes when you instantiate the object. It's not truly a method. It looks, it smells, it acts like a method, but it's actually a physical entity of a class. Let's go ahead and use the diagrammer to add it. Let's take a look at how it does it. So I'm going to do a right click on this. I'm going to do add. I'm going to add in a constructor. Now let's look at the code. It will put the constructor at the very top of the program, and you know it's a constructor because the constructor has exactly the same name. As you see right here, they have exactly the same names. We've seen constructors already when they're utilized. Let's go back to that desktop application that we were just using just a moment ago. Take a look at this. This is that demo that we were playing with a minute ago. Notice that I've got a form as a class. So here I've got this Test Tom Tools namespace, and then I've got this Form1 class. The name of my classes form 1. Now also notice at the very top I've got this thing that kind of looks like a method, but it doesn't have void, it doesn't have a data type in the middle of it. It just says public and form 1, and then it says initialize component. This on a form is the constructor. Now why is that constructor important? Well, if I look at the designer here, this is what I see. And if I run the program, this is what I see. The first thing that happens when you run your program is it has to build these objects. And that's what the constructor here does. It says when you instantiate form 1, automatically build all those controls. If I take this out, comment it out, and run it, I've got no controls. So it automatically executes initially. And I could do things within here too as well. But we're not going to do that right now. I just wanted to show you what it was at that point. Let's jump back over. And now I've got these tools here. I've got a constructor right here. In this constructor, I want to have the ability right now to, I want to have the ability to pass in first name and last name. So I still want the ability to do it this way, but I also want to have the ability to pass in first name and last name. So we saw in the previous example, I could create two properties, a first name property, a last name property, but to make that work, then I would have to do this. Because I don't need to pass those in if they're already in memory, so I would get rid of these guys right here. Just like that. Of course, the error that comes up is it says, where the heck is first name and last name coming from? So that's what we're going to do right now, is we're going to come back up here and we're going to create a constructor that deals with first name and last name. Constructors are very much like properties in that they need a helper variable. Since the constructor is passed in here as a value, that value only has a scope of within these brackets. That means that if I receive something here and I let the bracket end, I lose that value passed in. So the first thing I'm going to do is create a helper variable here. And I'm going to have those helper variables be string, and I'm going to use the same names I had before. First, we'll do a first name of type string, and we're going to do a string. You know what I did here is I meant to put private. And then we'll have last name here. Now, of course, if I'm going to deal with the overloaded third one down, then I would want to add a middle name. So now I've got these variables in here. I need to pass the information in to the constructor. So the constructor has to receive the values. Just like, what is it going to receive? That's going to receive a string, and we'll call that string that it receives first name. And it's going to receive another string. And again, the reason that I'm putting in no Hungarian notation here is because IntelliSense will ask for a first name string and a last name string. Just like that. So once I pass those values in, now I need to move them into those helper variables. Because remember now, as I mentioned before, these guys right here, they only have a scope of right here. So if I want these guys to, the values of these to be seen outside, I need to move them into a helper variable. Same thing I had to do with a property. So that's what I'm going to do right here. I'm going to come back and going to type in first name is equal to first name. And I got an error here because I got that semicolon. And then I want to say, last name is equal to first name. And that should be obviously last name. So again, let me explain what happens. We instantiate the object. Now, the only way to use this object, the only way to use it right now is by passing in these two values. When I pass those two values in, it's going to then set the value of first name and last name. Then what that's going to do, it's going to allow me now to come down here and run this method as O first name and O last name. So I've now got the ability to use this method in two different formats, although there will be an error we'll take a look at in just a second here that comes up that we'll have to address. I'm going to go ahead and build this guy. And now let's jump back over to our test app here and take a look at what we've got. So now notice I've got an error on the code that previously worked just fine, because it's telling me now that I cannot instantiate the object tomtools.tools the way I did, because it says there's only one way to use me right now. And in fact, I can't use the methods. I'm going to be blocked from using the methods approach, because the only way that I can use that object is by passing a value in here at tomtools. Let's go ahead and make this work. I'm going to go ahead for right now and comment this line out. And to use tomtools, it wants me to pass into it a first name and a last name. So for right now, I'm just going to hard code it in. I could be reading this out of a text box, but I'm just going to hard code in Fred and Flintstone. It's like that. And then notice that as soon as I do that, the error went away. In order to run this, all I have to do now is to say my tools, let me get rid of this, dot get full name. Notice I'm not passing anything into it. And this, of course, returns type string. So since I'm not passing anything into it, it knows that that other method that receives no arguments exists. Let's just see if it works. So it should, at the moment I click that test button, I should get Fred Flintstone to pop up. And it did. Now the challenge that I have, though, is it's no longer usable. Let's come back over here. I have to pass in this constructor. I have to pass a value in. And before I go on, I want to show you something though. The absence of a constructor is the same thing as an empty constructor. Comment this out right here. Right now I have no constructor whatsoever in here. This is commented out. There is no constructor, yet you know when I went back and instantiated it a minute ago that I used those parentheses anyway. If you have no constructor, it's equal to this right here. It's equal to public tools, just like this, like we had before, empty constructor, just like that. That's the equivalent. So no constructor or an empty constructor act exactly the same way, but it just so happens now that I have an empty constructor here, I can now utilize my methods. But I couldn't utilize my methods before when I just had these. So what that means, folks, and listen carefully, that means if I want to make it usable in both as a constructor, and you're going to have to think this through, and it makes sense if you think about it, I have to overload it, which means I have to have two different methods here. I'm going to take this out. So now I've got two different constructors in here. And it acts just like a method, folks. There's the signature right there. Tools, string, string, tools with nothing. If I instantiate tools with nothing, then it lets me come down below and use these methods that I have down below that let me pass values directly in. But if I instantiate tools with first name and last name, it allows me to use the empty constructor down here. And let's go back and prove it. Let's go back to my test application here. And right here, I'm passing values in as Fred Flintstone through the constructor. So I'm going to go ahead and run this and prove that it works. It worked. Let's, without changing anything at all in that object, let's pull this data out entirely right here. And let's pass it into the method. And did I rebuild my object? Because it's telling me that I got an error here. So let's go back over to my object and rebuild it. There it is. Jump back. And now the error is gone because I hadn't built it before. So now I'm using an empty constructor, but now I'm going to use the method approach. I'm passing the values into the method right here. And let's make sure that works. Fred Flintstone. So it just shows the versatility of an object. So let's go back and review exactly what we've looked at, folks, and you're going to have to play with this a bit. I would suggest that you sit down, you design your own methods a little bit, you design your own properties, you play with the constructor a little bit. You might have to go back in and rewatch this lecture. These are some of the most important tools that you're going to learn within our program. And when you leave my class and you step into Dave's 282 class, you're going to be learning the same concepts, but you're going to be using it with Ruby. But you'll find out with Ruby it has the same thing. You have constructors, you have properties, you have methods that you're going to receive it, and you try to create your object as universal as possible. Now I want to go back in before I break away and show you one other cool thing here. Go back to my tools. If all I have in my tools are methods, so I'm going to get rid of my constructors here entirely. No constructors here. I'm just going to use my methods, and that means that this method is going to be useless to me right here. I can't use this method right here because there's no way of passing in first name and last name. So I'm going to get rid of this method for right now. And what I end up with now are two different value returning methods. So there's a little trick here that I want to show you. There is a shortcut for tools if all you have are methods, and I don't need these variables any longer either. If I take this, and it's strictly methods right now, folks, so again, this will not work if I'm using properties and I don't want to use constructors with it. I just want to use methods. I can go back up to this class and make it a special type of class. If I take and put the word static right here, and I make each one of my methods down below static, something unique happens within my objects. Everything works fine here. I'm now going to rebuild it. There you go. It's built. And now let's jump back over to the test application. And I'm going to change things around a little bit. Notice I've got errors here. And the reason I have errors is you do not have to instantiate a static class. Watch this. I'm going to take this out entirely. Down here. So before I was instantiating my tools, now what I can do is go directly to the object and not have to instantiate a my tool. So I'm going to get rid of this guy right here. And right at this point, I'm going to get rid of the instantiated name, and watch this. I'm going to do tomtools.tools. Check this out. I can use it directly. I don't have to instantiate it. So if you're going to create a toolbox and all you have in that toolbox are public methods, you want to go back in and make that class static, and you want to make all of the tools static. That way you just use the tools. Here's the name of the method right here that I just created. I'm utilizing, and it should work exactly the same way. But the issue again is it only works on public methods. One last thing that I probably should point out over here is that you normally don't put work inside of a public in a public method. Normally what you're going to want to do is you're going to want to put that work inside of a private method. For example, I might want to go back out there and have a public string that returns back to you whatever information you want, but when you pass information in, rather than doing all the work here, I would then create a private method down below and have all the work done in the private method and have it return that information to the public method. Now, why is that important? You know, it's really just a security thing. I've never really been convinced that that really provides a lot more security, but from an object-oriented approach, you always want to encapsulate all of your logic, if you will, into private methods and use them with public methods. You know, the fact is if somebody hacks your code, they're going to get the public and private methods anyway. But I believe the concept is that it doesn't give any semblance at all of that private logic that you might put inside of it. And another thing I should point out too is that a class obviously can receive information from another class. But before I go on, I want to show you another thing here that I should have showed you before. And I'm going to close out this guy right here. And we know that I'm back on this basic form that we had before here. right? There's this form right here. We know that a form is a class, right? How do we know it's a class? Look, we look at the code, we see that the form is a class right off the bat. So if it's a class, we can do everything with a form that we can do with a class, right? So let me come back out here and show you what I'm talking about. Up to this point, we've been dealing with single form applications. But what if I want to add a second form in, and I want to be able to pass information from the first form to the second form, or from the second form back to the first form? So really what I want to do right now is, let's go back, take a look at this code. I'm going to keep things very simple here. Let's take this out entirely. And when I type a number in here and I click test, what I want to do is I want to open up another form and just pass that value to that second form just to prove that I can do it. And I can do that in a variety of different ways, folks. I could do it in a public method on that form, I could do it in a constructor on that form, or I could do it as a property. Let's do it as a constructor because that appears to be the easiest way initially. So I'm going to come back over to my form, to my project. I'm going to add in, and we're going to keep this very simple right now, a new item. And I want it to be a Windows form. I should have named it something different. We'll just leave it as Windows Form 2. And on Windows Form 2 now, I'm going to open up the code. And there's my constructor right there. You see that? Now, when I instantiate Windows Form 2, what I'd like to do is require a value to be passed to Windows Form 2. So I'm going to pass to it, let's see, I'm going to pass to it a string. And I want that string to be, I'm just going to call it data for right now. Okay. I still want the initialized form component here. And then on top of this, what I need to do is create a helper variable. So I'm going to do a string OData. And then my form, right after I initialize that component, I can either use a form load event, which means I could come back to the form, double click on the form, and make the value appear on the screen. So let's drop a label on here to show I can make it work. There's a label right there. Let's enlarge it. Just like that. And then whatever value's passed, I want that label to have in it. So let's view the code. And as soon as it initializes that component, I have to have it do this first, otherwise the label won't exist. So I have to wait for the label to be created first from initialized component, and then I can now go back in and say label1.text is going to be equal to OData. Just like that. It's that simple. I'm passing data from one form to the next. So now I got to go back to my first form though and make a couple of changes. So when this button is pressed, I need to instantiate that form 2. Now check this out, folks. I can do form 2 dot. Now I didn't have to do tomtest.form2, although I could have done that. Why? Because I'm already in tomtest, so it's already within the same namespace. So I've got form 2, I want to call it maybe my form, is equal to a new, and look at that, form 2 pops up. Now watch what happens when I hit my left parenthesis for my constructor. It tells me it's looking for some kind of data to be passed into it. Okay, so what data do I want to pass into it? Let's just pass in the word hello. Could be coming out of a text box, by the way, folks. I'm just going to pass in, did I leave my, well, I left my text box there. Let's just pass in the value in text input. So I'm going to go back over here, and let's pass in text input dot text, just like that. Let's go ahead and run it. Oh, well, I passed the value in, but now I have to make the form show up. So now I got to do my form dot show. And there's two different shows. There's a show and a show dialog. Let me show you the difference between the two of them. So let's do the show first. And then let's go ahead and run it. So here's my first form right here. I click test. Well, I better put something in here. I click test. I want Tom to be passed through the constructor to form 2. Form 2 receives it and is going to plug it into that text box. Let's see if it works. Uh-oh, it didn't work. So let's find out why that is. So right here, I'm going to put a stop. Is that the right text box? Let's make sure that's text input. Let's run it and see what's happening. I type Tom in. I click test. It instantiates form 2 and it's going to pass that in. So it should jump to form 2 to the constructor, pass that in. Let's see if that works. So there's form 2. It received data. What did it receive? It received Tom. Oh, you know what I never did? I never moved the data. Remember, the problem that I have in form 2 here is that data dies at the end of the bracket here. So what I want to do is, oh, you know what? In this case, since I'm putting it directly in the label, I don't even really need this because data can go directly in. It would be if I did a form load event, I would have to have it. But now I can put it directly in. That should change things quite a bit. Let me go back to my original form 1, and take that stop out. Let's rerun it. Tom, test, and there's my Tom. Now, notice how I can jump back and forth between the two of these. If I don't want to be able to do that, then what I can do is I'll change this to a show dialog. And a show dialog then sets a precedence. And now I have to close this window to get back to this window. And in fact, this code right here will pause on that and wait for me to close it. So that's a pretty cool example. Now, I want to point out one other thing, as long as we're at it. What I could be passing across is a POD. I'm passing a single text box, but maybe this form has a whole bunch of information on it that I filled out. I would then pass the POD across to the form on the other end, and then I would have to receive that POD and instantiate it. But it's exactly the same thing, folks. Here I'm passing a single piece of data. That's why we use the PODs, is to fill all that data into the POD, and I would only have to pass a single item back to form 2. Now, granted, when I received it over here, I would have to parse it back into another object. So I would declare my POD here. I'd receive the POD as an argument, and I would plug it into the helper POD, if you will, down here. We'll take a look at an example of that hopefully later or in class demonstration. So hopefully this made sense, folks. And again, this is really, really powerful stuff. I've just touched the tip of the iceberg on it because these PODs can get extremely complex. You can imagine an organization like UPS, what a POD would look like for them to store their data, just if on mailing information, if you will. Or an organization like Amazon, who has a business object out there that manages all of it so that they have a website that uses that same business object, or desktop applications in their offices that use the same object. You want to try to consolidate as much as you can in one place, because when you change that one POD or you change that one business object or class, you're changing it for everybody at the same time. You don't have 5 different places that you have to go. So again, go back in if you have to, re-review this, and I would suggest that you start playing around with baby steps. If you have problems, come and see me.